Hello, my name is Trent Gilson, and for my SPED talk this week, we're going to talk about SQL Graph architecture. Normally, when you talk about graph architecture, it is a no SQL, but recently Microsoft has been pushing SQL Graph into their SQL Server capabilities. So starting off, we have to explain what makes a graph special. So starting off, graph is a collection of nodes with relationships. So with a graph, we have two special types, and there's the node type and the edge type. And when you declare a table into the database, you declare if it's a node table or an edge table. And your nodes are going to be your entities. So for instance, a person would be a node table, and you'd have your name and whatever else. And the edge table would be a relationship it has. So for instance, I could have a table of cities, and those would be nodes. And I could have a person live in as an edge in a city. So for my edge table, it would be lives in, and then the node would be the city. So in the edge table, if you're connecting them, you would give out what your node is. So I'd say I'm person 1, person node ID 1, and I would say I live in, and then you say whatever ID is of the node for cities. So here's a little sample I made to help better visualize it. So for instance, all the squares are your node tables. So we have person nodes, we have pet nodes, we have cat nodes, dog node, fish nodes. And then each of the arrows is a relationship edge table. So if we look at the persons, the person has a nose table, and it's connected to itself, so a person can nose another person. It also has an owns relationship, so a person can own a pet, and then it has a like, so a person could like a dog. And you could also connect it to whatever you want. You can have as many edges as you want. And you can look at the pets table. A pet has a master, and a pet is high maintenance or it's low maintenance. So if we wanted to look for a thing, we could say, I want to look for a pet whose master knows me. And so you would just go along the scale and follow the edges. So the new thing that's included in a graph architecture is the match statement. And it's really helpful for searching the where clause. So for instance, in that first statement, I'm trying to look for a person's name who likes dogs and who owns a pet cat. And so if you see here, I'm searching for the name, and I have to declare all the tables I'm searching for. So I have person, likes, owns, pet, and high maintenance. Now, even though person is the only node table, and that's what I'm searching for, I need to include all of the edge and other node tables that I'm going to be traversing through. Now for the match statement right here, at the very bottom, I have to do like this. So first we say what node we are that I'm looking for, and then you say with the dash and the parentheses, you say what the edge table is, what the relationship is. So for right now, I'm looking for a person who likes dogs. And then you put the arrow for the last node. And then if you also, I can include it with an and or clause. And so I'm also looking for a person who owns a pet cat. And so overall, it'll give me a person name of all the people who like dogs and people who have a pet cat. Now for the second one, it's a little more complicated. So right now, I'm searching for a person's name who I know who also has a pet. So if we're going to do 2-person searches, we have to have 2 different persons. So we have person 2, and I'm looking for their name, and I declare person 1 into person 2. And so right now in the match clause, I say person 1, which is me. I say if I'm looking for someone who I know, person 2, and they have a pet cat. And so it goes both ways. And down here we put down where my ID is. Now the advantages of a graph relationship is it really helps for many-to-many relationships because you can have as many connections as you want from nodes. It's also really easy to analyze and visualize because there's a clear connection between everything. It's semantically really easy because you can see the match statement and it's really easy to read. It's really helpful for hierarchical data and has a much faster query time because everything is so clearly defined and it's already indexed. And that is my SPED talk.